nets are basically like wrapping up paper. So imagine you had a cube-shaped present or object. Well, if you were to wrap that up with say wrapping up paper, and then you were so it's only one piece, and it's only one layer deep. So you're not allowed to have the paper go over the edge. Then what's the smallest piece of wrapping up paper that would actually cover this cube? So you just look at the thing and go, okay, I have a top piece, so you know that top square, and I have the square at the bottom, which would be they're shaded there, and then you have the middle layer. So you've got the face in front, there's that face there, there's a face just behind here, and there's a face at the back. So that means if that face was the front, or that center layer is, or the center layer consists of 4 square shaped pieces. So again, if it was drawn correctly, so if you have 4 square size pieces, so all the squares of this cube are the same size, so these 4 pieces would wrap around that middle layer and cover it. But you then have an extra piece for the top and the bottom, so we draw it like that. Now you could also have drawn it on any of these squares, so I could have put a one on top and bottom of this one, but then I wouldn't have it here. So if I had a piece of paper which was like this, then I could wrap a cube. So with paper like this. So what you can check is that the area of this paper is equal to the surface area of the object. So area of net, so we call this wrapping up paper like object the net of the 3D object. So the area of net of the cube, so or of cube, is equal to surface area of the cube. So actually, what is surface area? Because we haven't actually mentioned that. So in the same way that in 2 dimensions you have a square and which has an area, so if the edges have length L, the area is equal to L squared, the perimeter is equal to 4L. So if we add up all the length of each of the edges, that's equal to 4L. So that's what we get in 2D. In 3D, we have a so that's not much of a cube, since that's more of a rectangle there, but the equivalent, we have the volume is equal to L cubed, and the surface area is equal to the area of the 6 squares, the 6 faces. So we have a face on top, a face below, and 4 faces along the middle. So we have, that's the surface area is equal to 6L squared, because each of the faces is a square with area L squared. So the surface area of the cube is 6L squared, so then the area of the net should equal 6L squared. And we can count here that there's 1, 2, 3, 4, 5, 6 squares, each of which has an area of L squared, so the area of the net is equal to the surface area of the cube. So another way you can think of it is that you can work out the surface area by first figuring out what the net is, so that you've correctly visualized or captured what the surface area of the object is, and then you can work out the surface area of or the area of the net easily. The cube is the easiest thing in a way, but so say you had a Toblerone paste shaped object like this. So you have a triangle there and a triangle back end. So the wrapping of paper around this would be, well, the middle layer is 3 pieces, so 3 rectangles. It's 3 because it's a triangle. So we have a rectangle here, a rectangle on the opposite side, and a rectangle below. So if I say that's the length, and if all 3 sides of the edges are the same length, I'm going to say. So I'll just call that the width. And so that length of the triangle is the same, and that width, the width of that edge is also the same. So if that's the case, we'd have the middle, the body of the Toblerone shaped object would have the 3 rectangles. You have length L and width W, and then we'd also have the triangle. So say that middle thing has the I'll put the two triangles on the end of the middle rectangle. I could have put them at the end of the top or the bottom, but basically, as we had in the case above, we want that the surface area of this is equal to the surface area of a Toblerone. So this surface area is going to be 3LW, since you have three rectangular parts of it, and then you have 2 times the area of the triangles. So triangle area. And the area of a equilateral triangle, so that's going to be 3LW plus 2 times W squared root 3/4, since that's the area of an equilateral triangle. So what we did here was just use the idea of nets, starting with our three-dimensional object. We determined the net, which is the area of which is the surface area of the three-dimensional object that we're dealing with, which can be thought of as the wrapping up paper, like the minimal wrapping up paper that could cover the object that we're dealing with. And we can see for this object, which is like a Toblerone, it's got 3 rectangular faces and 2 triangular ones. So that's why our net has 3 rectangular parts and 2 triangular. Then we can work out the area of each of the rectangles easily, because it's just the length times the width. And the area of the triangular parts is, well, we look up, what is the area of an equilateral triangle with W, and multiply that by 2, since of course there are the 2 faces in this case. So that's pretty much all there is to nets. You might also be asked to work out what the net is of a cylinder, but it's the same process. We can see that the main body is, well, that has, say, height L and width, well, that's the radius, or that's the circumference of that circle. So say the circle on top has radius r, so then the circumference is going to be 2 pi r. So our rectangular piece, it's going to be length L, and that's going to be 2 pi r, because that's, as I said, the circumference. And then you have 2 circular pieces, so you can just attach a circle of, well, pi r squared somewhere along. So I'll just put it in the middle then. So we have 2 circular pieces attached somewhere along the body, the rectangular bits, because those would then cover the top and bottom of the cylinders. So that would be, the net of a cylinder.